Okay. So as she said, my name is Becca. I'm a data scientist with Duo Security. We're part of Cisco Secure. I'm presenting this work in collaboration with my former colleague, Rich Harang, who's now with NVIDIA. And there have been a lot of awesome talks the last 2 days about graphs and embeddings and neural networks, and I'm going to talk about matching. Specifically, how we can enhance 2FA security and precision using geolocation, IP-based geolocation in a way that is usable and privacy preserving. So first, we're going to just step through the 2FA authentication flow. So it's 2FA, you have two devices, an access device and an authentication device. The access device is what you use to initiate your authentication. That's where you enter your credentials and you step off this additional authentication flow. From there, the 2FA provider will send a prompt to your authentication device. That is where you, the user, will approve some kind of push notification, SMS, you know the deal. That goes back to the 2FA provider and they say, okay, great. You have accepted the authentication. We will let you into the service on your access device. So an important assumption here is that we're trusting that these devices are held and used by the same user, right? And something that we can use to assess that is whether or not they're in the same location, right? That might be a risk signal if we perceive the devices to be in a different place. So we might say if we assess them to be in a different location from one another, we can introduce some sort of additional security check. So in our vocabulary, we refer to this as a step up. You may have heard of this in risk-based authentication. So we'll call it a step up for this context, and I'll explain it a little bit more later. So in order to measure whether or not they're in the same location, we have to have a way of measuring location of these devices. And there's a few ways that we can do this. We can use GPS signals, Wi-Fi based positioning, or IP-based geolocation. And as you may have guessed from the title of the talk, we're going to focus on the third one. And there's a few reasons for that. The first is that these first two get a little bit too precise for what we need, right? In order to know if these devices are in the same place, we don't necessarily need to know the exact location of the user. That's data that we neither want nor need to do this, to solve this problem, right? And the other problem is that they sometimes require additional permissions from the users. And I don't know about you, but if my 2FA provider all of a sudden needed to know my exact location and prompted me for that, I wouldn't be too excited about it. So we're going to focus on IP-based geolocation. This is really nice for a few reasons, one of which being we do not need any additional permissions to use their IP address to get their location, right? We get the IP address with the request. But you may be thinking like IP addresses are pretty unreliable measures of location. I looked up my IP address here just before this, and it said I was in Baltimore, which I'm not. I looked up my IP address when I was home in Denver, Colorado, and one database said I was in Vail, which would have been cool, and another said I was in Vegas. So they think I'm a lot cooler than I am, which is fine. So it turns out this isn't actually a problem, right? To figure out if these two devices are in the same place or if they're not in the same place, we don't actually need to know exactly where they are. We can just use some really coarse measurement to say, hey, if the devices appear to be in different countries, we should do this step up, right? We shouldn't inherently trust them. And so this gets us to another point, which is that like we're doing this assessment at the moment of the authentication. So we don't have time to query a large model, to turn out some probability, to assess distance, right? We just need to be able to do this really quickly to make the decision in the auth flow. So what would this look like? We have our access device, our access device, our auth device. They have two different IP addresses, and they both hit the same 2FA provider. The user has accepted the push. They send their IP address. We, the 2FA provider, look up the IP addresses in our database, and we see that they're in different countries. This is not imaginary. This happens. It is something that we've seen in real attacks. And the common attack vector is that we have an attacker in another country who has an access device. They have phished the user's credentials through some social engineering, and now they've started to spam them with push authentications. And I know you might be thinking, who on earth would accept a push notification from somebody that they did not initiate the authentication flow? A lot of people, it turns out. So we need some way to mitigate this, right? So as we said, if we detect that they're in different countries, a simple thing we can do is introduce an additional security check. In our product, we call this a verified push. You may have seen something similar in Google Authenticator. You may have seen it with Duo itself. Essentially, your authentication device is shown a 6-digit code and you have to enter that 6-digit code on the access device. A lot of people do similar things, but this is how we do it. And again, this isn't the second factor itself. This is after you have accepted that push, or after that push has hit your authentication device, you're then prompted with this additional check. So you as a user might be thinking, that sounds like a lot of extra friction, right? We don't want to introduce friction, right, where it's not necessary. One of our core principles as a security provider is usability, right? A security system that isn't usable isn't secure, because nobody's going to want to use it. So we have to make sure when we're introducing this friction that we're really precise about when we do it. So some results. I'll talk about the graph, but the first thing to note is that when we talk about results for our systems, oftentimes we're not talking about precision, recall, accuracy. We're talking about the usability. We do not have a ton of labels in our data set. We're talking about fraud detection in 2FA systems, which is inherently a really imbalanced data set. Like, attacks on 2FA systems are inherently rare, and we probably have a lot of false negatives that we completely miss. Our true positives are sparse. They're often pretty subjective. We don't have a core labeling mechanism. As we've heard from people previously today, labels are really difficult. So what we want to do is look for heuristics where we know that there is a risk, and we want to make sure that we're not introducing too much friction. So let's talk about the graph. This is the percent of authentications impacted per user relative to the percentage of users that experience that amount of impact. So this was measured over 120,000 users from a random sample of our customers. And we can see that on the whole, most users experience very little impact. And this is to be expected. Most of the time, your workflow does not involve your devices appearing to be in different countries, right? But we do see a non-zero amount of users who have a really, really high level of impact, right? In fact, we see some users for whom 100% of their authentications would be met with this extra friction. So why is this, right? Some users just have a job or a workflow or a use case that involves their devices appearing to be in different countries, right? We've all used a VPN to watch French Netflix. Maybe that's just me. But there are a lot of ways in which your devices would appear to be in different countries that we know are not inherently malicious, right? So what can we do about this? So we can say, okay, if we see that these devices appear to be in different countries, we can take a few actions to suppress in the following situations. So the first is looking at this pair of country codes. So we say the access device has a country code, the authentication device has a country code. If these two things mismatch, but we've seen that exact pair before, and they successfully completed a stepped-up authentication, a more secure authentication, then we will not introduce this additional check. Similarly, if that access device's IP address has been seen before in a country code mismatch, and we have done this successful step up, they've completed it, we'll suppress the step up. And then lastly, we look at something called the Wi-Fi fingerprint. And I know you're thinking, you said you weren't going to do Wi-Fi based positioning, and we're not. We're going to do Wi-Fi based co-location. Okay. This isn't a talk about Wi-Fi fingerprinting, but I'm just going to overview this really quickly. So the way that we do this is we have a device key that comes from our endpoint software that the user will have on their access device. So this is our software that they've installed. That's a unique key for their device. We have then for every network that is reachable to this access device, we have the SSID and the BSSID. We concatenate these together and we hash them. And that list of hashes turns into their Wi-Fi fingerprint. So if we see a country code mismatch, but that access device's Wi-Fi fingerprint has been seen in the past 30 days and has successfully completed this step up, we will suppress in this situation. Again, no, we're not using any of their actual personal information. We're using a hashed representation of it. And we're not using it to figure out exactly where they are, right? You often hear about Wi-Fi based positioning, and it's talking about where are you within your house? Right? We don't want to know. All we want to know is if you've been in this vicinity of networks before, and if so, we'll say, okay, we trust your access device, even though there's something weird going on with your network. So we have our country code mismatch step up rule, and we have these 3 suppression mechanisms. And then we'll see that they lead to a really vast improvement in the usability of this system. So recall that prior, with just our country code mismatch rule, we had about 2.5% of users that were having 10% of their authentication stepped up. Imagine 1 in every 10 of your authentications, you have to pull out your phone and enter a code, right? That is not the experience that we want our users to have, especially when we have a way of trusting their devices. So with our new improved mechanism, we see that that number goes down to 0.3% of users experiencing this 10% step-up rate or higher. Additionally, prior, we had some users who had 90 to 100% of their authentication stepped up. That number goes to 0 with this suppression mechanism. This is a log scale y-axis, by the way, if you can't see that, so it's not as drastic as it looks. Additionally, we'll look at the customer scope, which is zoomed out. I know if you're in the back or if you're behind someone tall, you're like, Becca, those are the same graphs. They're different. Okay. And so what we're getting at here is that there were some customers for whom they had a lot of highly impacted users. So this is what we really want to look out for. The customers are the ones that care about their users' experience, and they're going to communicate that to us. And so we saw for the very much impacted customers, we saw the volume of users that were highly impacted decrease by over 80%, which is a huge win for us in usable security. So what did we learn? Basically, we learned a way to enhance security using geolocation, but in a way that preserves the user's privacy, keeps that at the forefront, and also keeps their experience at the forefront, right? This is really important to us. And we found a way to do that and implement it in a way that was not overly complicated. We can assess it at the moment of the authentication, and we can explain it to customers. This is something that's really important as well. It's not a black box. We're saying, hey, we've seen this mismatch before. We have a few suppression mechanisms in place, and they're able to understand what we're doing and why. So thank you.